All right, let's talk about RAG, Retrieval-Augmented Generation. It's the talk of the town in AI, right? But let's get real for a second. Beyond all the hype, what actually makes a RAG system sing? Most people, they immediately point to the LLM, the big brain model. But here's the thing. They're looking in completely the wrong place. The secret, it isn't in the AI's brain. It's in its library. And today, we're going to dive deep into why the structure of your knowledge base isn't just important, it's everything. So here's our game plan. First, we're going to tear RAG down a bit and find its biggest, most foundational flaw. Then, we'll build it back up with something called the structure-first principle. From there, we'll zoom in on the tiny details, the microstructures, and then zoom back out to the big picture, the macrostructures. We'll even see how all this helps defeat something called the distraction effect. And, of course, we'll wrap up by taking a peek at what's next for RAG. Sound good? Let's get into it. All right, first up, what is this huge flaw I'm talking about? Well, to find it, we've got to pop the hood and see how a standard RAG system actually works. Okay, so the basic RAG pipeline is actually pretty straightforward. It's a three-step dance. Step 1, indexing. This is where you feed it all your documents, and it chops them up into little knowledge chunks to create a library. Step 2, retrieval. When you ask a question, the system goes hunting for the most relevant chunks from that library. And finally, step 3, generation. It takes your question, adds those chunks it found, and hands the whole package over to the LLM to write a nice, fact-based answer. But here's the absolute kicker. This isn't just a list of steps. It's a chain of dominoes. If the first one is wobbly, the whole thing comes crashing down. And that right there, that brings us to the core of the problem. You've heard this a million times, but for RAG, it's the absolute gospel. Garbage in, garbage out. I mean, you could have the most powerful, most expensive LLM on the planet, but if the context you feed it is junk, you're going to get junk out the other end. It's that simple. Just think about that financial firm. They lost real money because their RAG system was pulling up old, outdated regulations. The LLM, it was doing its job perfectly. The data it was handed was the real villain here. So what this really means is that the knowledge base, it's not just another component. No, it's the #1 performance bottleneck for the entire system. Any little mistake, any bit of sloppiness during that first indexing step, it doesn't just stay there. It cascades. It gets bigger and bigger down the line. Trying to improve your RAG system by just getting a fancier LLM, that's like trying to fix a crumbling skyscraper by putting a shiny new antenna on top. The foundation is cracked, and it's just not going to work. So once you really get that, it forces a pretty radical shift in how you think about building a RAG system that actually works. And that shift brings us to what we're calling the information structure first principle. The idea is so simple but so powerful. It's this. Stop obsessing over tweaking the retrieval algorithm or hot swapping the latest LLM. Instead, become completely obsessed with the architecture of your data, because that's where the real performance gains are hiding. When you build a clean, well-organized knowledge base from day one, you're not just fixing problems later, you're preventing them from ever happening in the first place. Okay, that sounds great in theory, right? But how do we actually do it? Well, we have to start at the ground level. We need to look at the single most basic building block of the whole system, the chunk. And this is where we run into a really important idea called semantic noise. Now think about how this works. A vector embedding tries to capture the meaning of a piece of text and turn it into a single point in space. So what happens if your chunk of text is talking about 3 completely different things? Well, that vector gets pulled in 3 different directions all at once. It ends up landing in this weird, meaningless middle spot that doesn't really represent any of the topics well. That confusion, that's semantic noise. And it's a huge reason why so many RAG systems pull up stuff that just feels random. And looking at the different strategies for chunking, you can really see how our thinking has evolved. We started with the most basic, almost brute force method, fixed size chunking. It's basically taking a digital sledgehammer to your documents and just chopping them up. Then we got a little smarter with recursive chunking, which at least respects natural boundaries like paragraphs and sentences. But where we are now, the real state-of-the-art is semantic chunking. This method actually uses an AI to read and understand the sentences, grouping them together based on their meaning. It's a total shift from just cutting text to intelligently crafting coherent chunks. This timeline really drives home that philosophical shift, doesn't it? We went from treating our data like it was just a long string of text to be sliced and diced to seeing it as a rich landscape of meaning that needs to be carefully and intelligently mapped out. And the future, it gets even wilder. People are talking about agentic chunking now, where you'd have an AI agent that looks at your content and dynamically figures out the absolute best way to structure it. Pretty cool stuff. All right, so let's say we've done all that. We have these perfect, semantically coherent chunks. We have our bricks. But, a pile of bricks isn't a house. Now we need the blueprint. It's time to talk about organizing these chunks into an intelligent macro structure.
Because if you don't have a plan, all you've got is just a flat, disorganized pile of chunks, and that's a nightmare for the user. Think about it. You ask a really specific question, and you get back this huge, vague chunk. Then you ask a broad, high-level question, and you get some tiny, granular detail. It's frustrating. To give people what they actually need, the ability to get both a bird's-eye view and a microscope view, you absolutely need hierarchy.
And one really clever solution to this is called the parent document retriever. The strategy is just brilliant in its simplicity. Here's how it works. You create small, specific child chunks so you can do a really precise search. But, and this is the key, when you find the perfect child chunk, you don't actually give that tiny snippet to the LLM. Instead, you go find its much larger parent document and give that to the LLM. It's genius. You get the laser-focused precision of small chunks for your search and the rich, meaningful context of large documents for your answer generation. The best of both worlds. But what if you need to do even more advanced reasoning? Well, then we can level up from simple hierarchies to knowledge graphs. This is a whole different ballgame. Instead of just storing chunks of text, a knowledge graph explicitly maps out the connections between things, the entities like people, places, concepts, and their relationships. This is what lets you answer those really tricky multi-hop questions. Something like, who directed the movie that starred the main actor from The Revenant? A standard vector search would just completely fall apart trying to answer that. But a knowledge graph? It can literally trace the path from the actor, to the movie, to the director. This is what elevates RAG from just a fancy search and summarize tool into a genuine reasoning engine. So all this talk about architecture circles back to a really practical, critical question. We know there's this fundamental trade-off, right? Small chunks are great for precision, but large chunks give the LLM the context it needs to generate a good answer. So, what's the verdict? Is there a perfect chunk size? Let's see what the research actually tells us. Well, the data is pretty clear. There is no magic number. Sorry. The optimal chunk size depends completely on your data and what you want to do with it. For something like a fact-based Q&A bot where you need quick, precise answers, small and punchy chunks, maybe around 64 tokens, are the way to go. But if you're dealing with complex stories or dense technical manuals, you need that broader context. So you'll want to go with much larger chunks, maybe up to 1024 tokens. It all comes back to matching your structure to your specific use case. Okay, let's tie all of this together, the coherent chunks, the intelligent hierarchies, because when you get these architectural pieces working in harmony, they create the ultimate defense system against what is arguably the single biggest threat to an LLM's accuracy.
And that threat has a name, the distraction effect. And it's a truly fascinating and kind of scary problem with LLMs. Get this. Even if the correct answer is sitting right there in the context you give the model, just having other irrelevant information in there alongside it can be enough to distract the LLM and make it give you the wrong answer. This distraction, this contextual noise, it's the direct symptom of a poorly designed information structure.
And this is why information architecture is your ultimate weapon against it. Think of every principle we've talked about as a different type of filter designed to boost the signal and cut out the noise. Semantic coherence, that filters out the noise inside each chunk. Hierarchical structures, they filter out context that's at the wrong level of detail. And something like metadata filtering is your most powerful tool. It lets you throw out entire documents based on date or source before the search even starts. It's all about delivering the cleanest possible signal to the LLM. When you look at it this way, it completely reframes what we're even doing here. Building a great knowledge base isn't just about data management or organization. It's prompt engineering at a massive scale. You're not just feeding the model data, you are meticulously designing the entire environment where the LLM does its thinking. You're shaping its reasoning process way before a user ever even asks a question. So, if we take this structure-first philosophy to its logical conclusion, where does that leave us? What does the future of RAG actually look like? Well, the writing's on the wall. We're clearly moving away from these static, pre-built knowledge bases and toward much more dynamic, intelligent systems. Just imagine AI agents that can restructure information on the fly,
perfectly tailored to each specific query. Or think about tools that can just ingest a ton of raw text and automatically build out a complex, interconnected knowledge graph. The future isn't going to be just one thing. It's probably going to be a smart hybrid architecture. You'll have RAG handling the data that changes all the time, working alongside finely tuned models that have a deep, baked-in understanding of your core, stable knowledge.
And all of this leaves us with one last big question to think about. For the last few years, the entire AI race has been about one thing: building bigger and bigger models. But what if we've been focused on the wrong race? What if the next huge leap forward in AI doesn't come from building a bigger brain, but from becoming a much, much better librarian? Maybe the future of AI won't be defined by the model builders, but by the master information architects who give those models a world worth thinking about. Thanks for tuning in.